Welcome to Train Signal. You're watching a lesson on connection interfaces and devices. Now, real quick, just to get things started here, let's just kind of do a quick overview of this one section of many motherboards that we looked at back in the motherboards lesson, and I said we would come back to. And this is where we're coming back to it. And that is basically, this is a real zoomed in picture of the back side of a motherboard. This is the part that would be facing out of the case that you install the motherboard into. And this has some of your basic input-output ports. So some of the examples we have here are something called PS2 ports, and I will tell you this is a little bit out of date in the sense that these ports do still exist, but most keyboards and mice, which is what would go into these ports, we'll revisit that in just a few minutes, most of them are now plugged in via USB. We don't use PS2 anymore. Next to that, we have this real big port, and a lot of people, that's probably the number one port that people will ask me, what's that? You know, this big honking connector, what goes in there? That's something called the parallel port. Okay, that's a 25-pin port. We will come back and revisit that as well. I will tell you just kind of quickly, typically that's where your printer in the old days would plug in. Then we have this 9-pin port, and this is what's known as a serial port. And there were a number of different things that we would plug into a serial port. And by the way, you know, speaking of pins, if you look at the parallel port and you look at the serial port, you should notice there's a little bit of a difference. The parallel port is just a grouping of holes, basically. It's got 25 holes. Whereas the serial port, you'll see it's 9 actual pins sticking out. And that's a big problem that a lot of people have is they'll hear that something is a male connector or a female connector or a male port and a female port, and they want to know what the difference is. Well, the parallel port would be an example of a female port, and the serial port would be the example of a male port. And I will tell you that if the parallel port is a female port, that means that the connector on the parallel cable, that connector would have to be a male connector with the pins sticking out so that it can go into the holes in the female parallel port. And then the flip side would be true about the serial port, where since it's a male port, the serial cable will then have a female connector. Okay, the males and females always have to go together. That's kind of where this male and female port came from, is which one has the pins. The males have the pins and the females have the holes. All right, enough of that. Moving along, these two ports on the right side down to the bottom are USB ports. Now that would be something that is a little bit more modern, something that's more common. Matter of fact, today's motherboards, you'll see fewer and fewer of the PS2 parallel and serial ports and more of the USB ports. And then this last one up above the USB ports is what a FireWire port looks like. All right, let's continue with our history lesson here, and let's talk about our legacy stuff. All right, serial ports, right? We were just talking about it's an old port. We really don't use it much anymore. It is typically a DB9 or a 9-pin port. I will tell you there is also, if you go way back, serial ports were also a male DB25 port. Okay, but it's been a long time since we've seen that. Again, this is what a serial cable would look like. Now, please be careful because it looks very similar to what a VGA video cable looks like, in the sense that the way the connector is designed and the fact that it's blue, or the actual connector itself is blue, you want to be real careful. But a VGA connector is actually a 15-pin port. It's 3 rows of 5. Okay, I know it seems weird. It's like, how do they fit that in the same space? But they do. And we'll take a look at that in a different lesson. But here we have the DB9, and notice that the connector on the cable itself is a female connector, whereas the port itself is a male port. We would use a serial cable in the old days to hook up an external modem, and I'm talking about a good old-fashioned dial-up modem, like a Hayes 56K modem. We don't really see that much anymore. Believe it or not, it was one of the original ports that we would plug mice into. Or is it really called mice if you're talking plural, but in the computer term, or is it mouses? That's a big debate a lot of people have. But anyway, we did plug mice or mouses in via a serial port connection way back when we first started using this thing called a mouse. The one thing that I would say we still use the serial port today is to hook up a console. And it's not so much that you'll hook up a console to the computer, but very often on certain different networking devices that don't have a typical monitor of their own. Now, again, it's a little bit of a history lesson, but we do still see it a little bit today. If you cannot manage these devices over the network, via Ethernet, what you do is you actually use a serial cable to plug the device over into the computer and have the computer then act as a terminal or a console to go ahead and manage the device. Now, when you actually get in and look at the literal ports from an operating system perspective, your serial ports are what's referred to as COM ports. And by default, typically there is COM 1, 2, 3, and 4. Now, this may seem weird because it's like, wait a minute, I don't see 4 serial cables in the back. Again, it's because we're still looking at things the way they were done in the old days. What you can actually do is you can assign, and I don't want to go too deep into this because it's old stuff, but you can assign any one of the 4 logical COM ports to be associated with the one physical serial port in the back of the computer if you only have the one. Now again, old news, we used to have this thing called the parallel port, and again, it's the DB25 connector, and this is actually a bad example. The illustration here is because it's actually, again, remember, it was female on the side of the back of the computer, and I have these cables here, and you'll notice that they're both showing female as well, which means they wouldn't work, but that's because the picture I grabbed is the wrong end of the cable. This is the end that would go in the other side, so the side that would go into the computer would end up being the male side. But don't worry about the male-female thing. The bottom line is that you have this 25-pin connector, and then you also have this thing called the Centronics connector, which I have on top, which was a little bit different of a connector. You typically, unless you go way back in time, you typically would not use the Centronics connector on the computer side. You would actually use that to hook up to the printer side. And on the printer port, there would be these little clips that would clip around the brackets that you see on the side of this connector. So again, what are we using these parallel cables for? Printers. I mean, it wasn't exclusively. There were other devices, but typically printers. Nice, simple answer. And again, in the operating system itself, how would you recognize parallel ports, or what would you assign to them? They'd be the LPT ports. Okay, so remember, COM ports are serial, LPT, parallel. And now we got our PS2 connectors. We have the green one, and then we have the purple one. Again, if you go far enough back in time, believe it or not, they didn't used to be colored. They would just be 2 of these round connectors with these pins, and then you have the little peg in the center there. And in the old days, it was really hard to tell which was which because, well, they were the same color, but it mattered. And back then, what we used to always say was the one that was on the outside most of the case. So whichever one was on the edge, that was the keyboard, and the one more towards the middle was the mouse. But then they went and color-coded them, made it life a lot easier. And the green one is the mouse, and the purple one is the keyboard. And then they even went to the extent where they started color-coding the connector on the mouse and on the keyboard, which didn't used to always be either. Now, speaking of mice, there are many different ways that we can connect a mouse to a computer. We have the old-fashioned serial mice. We have the old-fashioned, but not quite as old-fashioned, PS2 mice. One of the drawbacks, by the way, to using a PS2 mouse is that it's not hot swappable, meaning you can't plug it in live. You wouldn't necessarily fry the mouse. I mean, it could happen, but more specifically, it just wouldn't work. You'd have to reboot the computer before the mouse would start working. In today's world, everything is either wireless, where you'll have the actual wireless receiver that would be USB, plug into a USB port, and then the mouse, you could, as long as you were within the range, get a signal there. A lot of freedom there. That's what I'm actually using right now. And then we also have USB mice. So the point here is today's mice are all plugged in via USB, either on a cable or via wireless. And then we move over to the keyboards. Typically, in today's world, we do use a USB keyboard. In the older days, we'd use a PS2 keyboard. Now, interestingly enough, the keyboard that I have on the screen for you there, you'll notice it has both a green and a purple cable coming out of it. And the reason is because I just thought I would also show you that certain keyboards back in the day also would have either a trackball or a touchpad of some kind built into them. I mean, yes, we see that in laptops, but I'm talking about for a desktop system. And this particular keyboard has a touchpad in the lower right-hand corner of it. And so that means that this keyboard was acting as both a keyboard and a mouse, and that's why it had keyboard and a mouse connector as well. And then, of course, we also have the wireless keyboards, which, again, notice I've pulled one out that is a keyboard and touchpad combo. They don't always come that way. You have various options. But this particular wireless keyboard would work just like the wireless mouse in the sense that you would have the receiver, which would go ahead and plug into a USB port. And then as long as the keyboard was within range, you could go ahead and use it. Now, there is one last thing that I want to show you. This is, again, history lesson. Going back in time, I mentioned back in the motherboards lesson about the old AT motherboard and how you could recognize it because it had the old AT keyboard connector. Well, that's what we're looking at here. This is not something that you should see anywhere in today's day and age, but I thought I would show it to you just in case you come across some old computer equipment or it ever comes up. And what you're looking at on the left is the actual port that you'd find on the back of the motherboard. It's what it looked like. And then on the right is what the actual connector looks like on the cable coming from the keyboard that would plug into that connector. Although it may be difficult to tell from the picture, right? Because it's all a matter of proportion. I will tell you that this connector is larger than the PS2 connector. I mean, I don't know the exact measurements, but I mean it's probably pretty close to twice the diameter of the PS2 round connector. So it's notably bigger. You're not going to accidentally plug an AT connector into a PS2 port or the other way around. Now, here we have something called a KVM switch box. Right? And we take the letters KVM, and what do they stand for? They stand for keyboard, video, and mouse. If you have a situation where you have more than one computer on your desk, and these days with virtualization, this is kind of becoming a thing of the past, but in the old days, if you'd have 2 or 3 or 4 computers, or forget on your desk, let's say in a server room, right? In a rack, you have all these different servers, but you only want to have one keyboard, one mouse, and one monitor. This was nothing more than a switch box that allowed you to use a single keyboard, a single mouse, and I know we're not talking about it in this lesson, but a single monitor, and then you could switch between them as far as which computer they were controlling. All right. Now, in today's world, they still have these KVM boxes, but again, very often you won't see the PS2 connectors, but instead you'll have a bunch of USB connectors. But the concept is still the same. All right. How about we reel things, into a little bit closer to today's world and talk about the high-speed connection ports. Like the USB port, right? USB Universal Serial Bus. This connection port has replaced just about everything else that we've talked about. Okay? The devices that we said we plug into the serial port, well, first of all, most of those devices we just don't use anyway. But if we did, they would plug in probably via USB. How about printers? I mean, yeah, I know a lot of printers are networked now, but if they're not networked, then, maybe they're plugged directly into the computer. How? Oh, yeah, with a USB port. And then keyboards, mice, I've already been talking about that all along. So, yeah, USB ports are now, the standard connection port for just about everything. Now, USB has 3 different standards. There's USB 1, USB 2, and USB 3. And USB 1 had a maximum speed, right? So the data, how fast we can transmit data back and forth, a maximum speed of 12 megabits per second. USB 2 could then do, and this was a big deal at the time, could do 480 megabits per second. Okay, and the reason I say it's a big deal is because before then, we had this thing called FireWire, which we're going to talk about in just a moment. And FireWire was considered to be the super fast, the lightning fast, because it could do hundreds of megabits per second. And USB was a lowly old 12 megabits per second. But even that 480 megabits per second has become inadequate, right? We always want things faster and faster. We want it now. So USB 3 can now do up to 5 gigabits per second of maximum transmission speed. And I will tell you, I have external hard disk devices, okay, so external storage devices that I plug in via USB 3.0 and use them as like my main storage device. Meaning it's no longer a situation where, well, that's just my archive stuff out on my external drive. No, I can actually use that external drive for real-time stuff, even if there's a program that's actively using the data that's on that drive. Now, you need to be familiar with the various ports. And so USB Type A looks like this. This is the type of port that you would see typically on the computer itself. And a Type B port would look like this, where it's a little bit more squared off. And this is the type of port you would see on maybe a printer. Okay, certain other devices would have the Type B. Okay, so the Type A is typically on the computer side. Type B is on the device side. But then we get into the Mini A and the Mini B, which you can see is a smaller version. And then we even get into the Micro AB and the Micro B. Okay, so this is what the various ports look like. And you will find some of these minis and micros out on different devices. External storage devices I was just talking about very often will have a mini connector. Certain cell phones used to have, and even today might still have, the Mini B connector on it, whereas now they'll have the Micro B. Most of these external devices, especially things like cell phones and stuff like that. Now, one other thing that I'd like to tell you about USB that you should know is that USB actually has the capability, a single USB controller can handle up to 127 devices. Okay, now you might be thinking to yourself, how the heck am I going to do that? Well, this is done by connecting sometimes a USB hub, or you can even daisy chain certain USB devices. Okay, so even though I will tell you one controller can handle up to 127 devices, there's a couple things I want you to keep in mind. One is that you're only going to get a certain amount of performance, within the specifications that are listed. Okay, so as far as the speeds and whatnot, all 127 devices aren't going to get 480 megabits of the throughput. Okay, it's just not going to happen. They're going to share that. Okay, so understand that you have some performance issues when you hook up too many USB devices to a single controller. The second thing I want you to know is that although USB is a technology that does allow for certain smaller devices to be powered through the USB controller, you can't have more than 2 devices that are powered on that controller, because again, there's a very small amount of power that's going through there. So you can't have more than 2 devices without using some form of external power source. Now, I will tell you there are certain USB hubs that I've seen where the USB hub itself has its own power source. Okay, so you take the hub and you plug it into the wall, and then it is able to power multiple, beyond the 2 devices. Okay, but the original controller cannot. Then we move over into IEEE 1394. You know what IEEE is, right? I can never remember what it is. It's like the Institute of Electrical Engineering and something. I honestly don't remember. I could pull it up and tell you and sound like I know everything at all times of what I'm talking about, but I actually don't remember. Here's what I am going to tell you, though. The IEEE is a bunch of geeks. That's what it is. It's a bunch of geeks that set standards. And so if you ever see IEEE anything, that just means that organization set a standard that was accepted in the industry. Okay, things became an industry standard. So 1394 became the standard for FireWire. And the original FireWire, which is now known as S400, or sometimes it's just even 400. You don't even put the S with it. It's just FireWire 400. Depending on other specifics, it had the ability to transmit data at 100, 200, or 400 megabits per second. And again, compared to the 12 megabit USB, this seemed lightning fast. Or how about it seemed like FireWire, right? I mean, even just that name, FireWire, that sounds fast. Well, it is. But the problem is that then USB 2 came out and it could do 480 megabits per second, and that was faster than FireWire. So FireWire standards had to also improve, and we then moved on to the FireWire 800, 1600, and even 3200, which are the standards that represent FireWire that could handle 800 megabits, 1.6 gigabits, or 3.2 gigabits. It lines up perfectly with its name, right? 800 meaning 800 megabits, 1600 meaning 1600 megabits or 1.6 gig, and 3200 being 3200 megabits or 3.2 gig. Which again, FireWire and USB are in constant competition with each other in the sense that USB can also now do up to 5 gigabits. So FireWire needs to keep working, getting to be faster. But that's okay. It's good that the different standards are trying to compete with each other to be the go-to standard for speed, because they'll both just keep getting faster and faster and faster. Now, when it comes to the FireWire ports, this is what they look like. Okay, you got your 4-pin, 6-pin, and 9-pin alpha or beta. Okay, again, you can pretty much figure out very often you'll have a pin where it might be alpha on the computer and beta on the device. Although I will tell you, from what I've seen with FireWire, you can see these ports on either side at any time. Especially, I can tell you, I have a 4-pin alpha on my video camera, and then the 6-pin alpha is on my computer. All right, so just to give you a couple of examples. Now let's talk about a couple other random devices here that you should be familiar with. First of all, we have our barcode readers, right? You know what barcode looks like, right? You can see it in the different forms of scanners. Matter of fact, these days, I mean, barcode readers are everywhere. You have a barcode reader. The camera on your phone is a barcode reader, right? Through an app. If you have a smartphone, you can just take the camera from your phone, focus in on the barcode, and the app then will read it, and it can do various things. So you have, scanners in all different shapes and sizes to read these barcodes. You've got cameras, right? So you have like webcams. That's what we have a picture of here. And they can either be integrated, or the one pictured here would be an example of a USB. Where do we see them integrated? You see them integrated on your laptops, and you see them integrated, even built right into certain monitors that you might buy for your computer. Other types of cameras that we have our digital cameras, whether it be a digital still camera or a digital video camera. And very often, by the way, these digital cameras, they're not just good for taking digital pictures or digital video that you then can transfer over to your computer. You can actually hook many digital cameras and video cameras up to your computer to be used like a webcam. And very often, if you open up the little hidden doors on these cameras, see how we have the IEEE 1394? There's a perfect example right there of the 4-pin alpha right there. And then right below it, that little symbol that you see, that's the USB symbol. Okay, and looks to me from this picture, and sometimes it's hard to tell in a picture because it can be distorted, and it also depends on proportional size. That to me looks like a mini USB-B. I think that's what that one looks like to me. How about biometric sensors? What you're looking at there is an example of one that is built right into a laptop. That's one of the most common places you'll see it. It's this tiny little sensor. You rub your finger over it, and it reads your fingerprint. So again, can be integrated or could be an external device. And then something that is quickly becoming huge. Okay, again, if I was teaching this to you 10 years ago, we'd talk about touchscreens. We'd talk about a couple of different technologies of touchscreens that they were, still in the early stages of dabbling around with. Whereas in today's world, everything's going touch. I mean, we've got operating systems that are now based off of touch, whether it be for tablets, right? We see like the iOS and the Android on our tablets and on our phones, and then you have Windows Mobile, which now, as of the time that I'm recording this for you, we now have Windows 8, which is an operating system that is, works wonderful with touch, even for just your actual desktop PC. Okay, so you need to keep in mind that touch screens are considered by some to be where we're heading. Whereas in this lesson, I've talked to you about how keyboards and mice, how they use serial or PS2 connectors or AT connectors, things like that. Well, some feel that 10 years from now, I could be having this conversation with you, and I would say, here's a history lesson for you. We used to use this thing called a keyboard and a mouse, and we don't anymore. Now everything's just done on the touch screen. Okay, so you want to keep in mind that this is also something that is going to become more and more prominent in today's computers. And that does bring us to the end of this lesson. And I know that this lesson may have seemed almost more like a history lesson than a current lesson, but I mean, here's the deal, and here's what's current. It doesn't matter if it's the old way or the new way. There has to be a way for you, the human, to be able to interact with the computer. And so we need some form of connection devices, or we even could sometimes, we used to refer to them as input-output devices. So we need to be able to have these things to be able to go ahead and, as a human, communicate with the computer and have the computer have the ability to spit stuff out, whether it be on a monitor, and I know we didn't talk about monitors, that's a whole separate lesson, video itself, or printers, if you want to put something on paper, or in the case of, even at the very end, we talked about touch screens, right? Being able to just see everything, touch everything, move everything. It's all about the human interacting with the computer. And that's what we talked about in this lesson. So I thank you for watching, and I will see you in the next lesson.